The main physics ideas for this week were how calculus is applied in physics, a brief overview of what acceleration is and how it's applied in Newton's second law, how to estimate brief interactions and how to do that using the Python, and the fundamental interactions of both gravity and electricity. I learned that acceleration is just the change in velocity over time, and it's also the derivative of velocity. I also learned that when you're trying to study an object's acceleration, you can most simply just do it by observing how it moves, like just watching it. I also learned how to estimate brief interactions using Newton's second law. Finally, I learned that electricity is measured in coulombs, and the direction of electric force is determined by the charges of the objects being studied. So if both objects have the same charge, being positive or negative, they will repel each other. And if they have opposite charges, they will attract each other. And you have to keep that in mind when you're estimating the force of electric charges on objects. I already knew how gravitation worked and how the gravitational constant is 9.8 if you're close to Earth's surface. If not, you have to do some other calculations. Along with this, I also knew where calculus came into play and how it came into play in physics. Something that really did spark my curiosity, though, was the fact that when there are 3 or more objects that you're trying to calculate forces on, you can't physically do it by hand as you would maybe with 2 objects. You have to use a computational model in order to figure that out and get an accurate result. It didn't relate to my area of study, but in the last video on electric forces, I do see how that could relate to my area of study, because in neuroscience, there's a lot of ionic charges and interactions between those ions occurring within the cell. So calculating forces could come into play maybe with pumps or protein channels or something in the future. The topic that seemed the most confusing to me was the estimating brief interactions, just because it was the most formulaic and most in-depth, and I haven't really seen it before. I haven't followed up on it outside of the videos because I think I can grasp it more fully once I go to lecture and attempt the homework by myself. But I think if I do struggle with it, the instructor notes and the Feynman lecture online will be the most beneficial resources to me personally. I feel like I typically learn better from lectures and professor notes and examples being worked out with me than I do from reading a textbook. So I probably won't read the textbook unless I really don't get it after looking at the lectures. So being able to see those notes and examples will really help me apply the concepts in the problems I come across, maybe in homework or on exams in the future.